Hi friends, this is Sarvajin here. Welcome to my networking channel. Hope all are doing good. And today let us debug the OSPFV3 issues, version 3 issues. So this is the version we are using for IPv6. So I have connected R1 and R2, and the interface I configured as 2001:1, and this is for 2. So both should reside in the same subnet, right? So this is an thing I have configured. So let us debug the issue. So for some reason R1 is not able to establish the OSPV3 neighbor relationship with R2. So we have to go and debug the issue. So now let us go to the individual router and let us check the interfaces. So immediately I'm seeing a error, right? That is OSPV3 area 4 mismatch. So that is a mismatch error I'm seeing, right? So let us see. Show IPv6 OSPF interface fast Ethernet. So this is a way how to troubleshoot fast Ethernet 1/0. So this is a command show IPv6 OSPF interface fast Ethernet 1/0. And similarly, let us go to R2 show IPv6 OSPF interface fast Ethernet 1/0. Okay. So now let us see both the differences. So first let us compare both the things. First it is in area 1, right? That is the thing you are seeing. And this router I configured is in area 0. So that is the reason there is a mismatch in the area. So now let us fix the first issue. Go to the configuration mode and interface fast Ethernet 1/0, no IPv6 OSPF 100 area 0. So we have to configure it area, sorry, no IPv6 OSPF area 1. Then I have to configure with area 0, right? So the both should be in the same area. So now let us check it out. Show run include OSPF. So it is able to see IPv6 OSPF 100 area 0, and both the thing I have configured the same area. So let us check the interface now. So IPv6 OSPF interface faster than 1/0. So which is in area 0, and this also is in area 0. So first error is fixed. So now let us check the neighbor relationship. Show IPv6 OSPF neighbor. That is a command I have to check for neighbor. Still the neighbor relationship is not establishing. So now let us understand what is the main reason. So there are several possible reasons for R1 not establishing the OSPv3 neighbor relationship. So here you are able to see, right? Here it is showing a non-broadcast environment, and here you are seeing the network as a broadcast. So that should not be the case. So always the default type is broadcast. So I have to change this to broadcast. So what we can do, go to the configuration mode. So this is the second issue we are fixing. Interface faster than at 1/0, no IP OSPF network. So automatically it will change it to the default value, right? So let us check now. Show IPv6 interface, right? Faster than 1/0. So now this is showing as non-broadcast, right? So it is not remote. So now let us check it out. Go to faster than 1/0, no ISP over network, non-broadcast. So now let us check. So still it is showing non-broadcast, right? So let us check why it is not removing. Okay. So go to interface fast Ethernet 1/0, no no IPv6. So no IPv6 OSPF network non-broadcast. So I have to given us IP. So since it is an IPv6, we have to give IPv6 OSPF network non-broadcast, or we can give simply IPv6 OSPF network. So now let us check it out. Show IPv6 interface. So this is also in a broadcast environment, and this is also in a broadcast environment, and this is in area 0, and this is also in area 0. So now let us check the neighbor relationship. IP OSPF neighbor, right? Show IPv6 OSPF neighbor. So still the neighbor relationship is not established. Now let us check the interval, hello and the dead interval. I am seeing some differences. So hello it is showing 20 and dead interval is 80. Here it is showing the hello and is 10 and dead is 40. So this is a default interval. Hello is 10 and dead interval is 40. But here it is showing different interval. So we can remove the interval. So it will take the default interval. Go to interface faster than 1/0. IPv6 OSPF hello interval. IPv6 OSPF hello interval, right? So we have to give no IPv6 OSPF hello interval and no IPv6 OSPF dead interval. So that should set to the default value. So now let us check it out. It should show us 10 and 40. So now let us check the interface. So now let us see the interface. Interface is showing 10 and 40 hello. So this is also showing 10 and 40. So three issues we have fixed. First, it is showing in the different area, right? Area 1. So now both are in the same area. Second thing, I fixed the broadcast network. So the network should be the same. So both remain the same network, that is broadcast network. And the third one, what we have fixed is hello and the interval should be same. Hello is 10 and 40. So here is also 10 and 40. So now let us check the neighbor relationship. Show IP OSPF neighbor. Yeah, we are able to see the neighbor. So the neighbor, this is nothing but a router ID. So router ID for IPv6 OSPF version 3, I can give even IPv4 router ID. This is 2.2.2 I given us for R2. And for R1, I given us 1.1.1. That's the reason you are seeing this is a neighbor ID and this is a designated router. Let us see for R2, show IPv6 OSPF neighbor. So we're able to see this is elected as a BDR, right? A neighbor, this is nothing but neighbor is a BDR. So this shows neighbor router is a BDR, this R1 is a BDR, and R2 is selected as a DR environment. That's the thing. So full is nothing but it is already established with the full synchronized with the full database. That is the reason for full actually. So first it will go to the down init two-way, just like IPv4 it will work, right? OSP version 2. So it will just like it will go for down init two-way start, exchange, loading, then it will go to full. Full is nothing but it already synchronized with the full database. So this neighbor router is elected as a DR. That's the reason showing us full DR. So this neighbor is elected as a BDR. That's the reason showing us full BDR, right? So now you are understanding the scenario. Now let us check the routing table of the OSPF. Show IPv6 route OSPF. Okay, you are able to see, right? The destination network, because it is 2001:2, we are able to see the destination networks. Let us check in R2 also. Show IPv6 route OSPF. You are able to see, right? 2001 colon. Let us ping it. Ping 2001 colon 1. I'm able to ping the remote network and let us see from R1 side also. 2001 colon 2. So I'm able to ping R1 to R2 and R2 to R1. I'm able to see the neighbor relationship and we are able to see the OSPF routing entries also. So now let us see one more thing is pending. Let us do a packet capture and check. Start packet. How to do? Go to this link, right click, start capture and click OK. So now it is running the capture. Let us see. So now you can see the OSP version packets. So IPv6 will show all the packets. So you're able to see, right? OSP packet, hello, and the hello packet you are seeing, right? So always the source address will be the link local address and the destination address will be FF025. So this is a destination is nothing but this is a destination address for a multicast, right? So this address it is used for sharing the hello and the update packet. That's the thing, key point you have to remember. And I hope you enjoy this video. I already shown how to troubleshoot the OSPF issue. So there are three things you always keep it in mind. First thing is both should be in the same area and also check the hello and the dead interval. It should be default is 10 and 40. And third also you check the default network. So default network is a broadcast network. So both it is showing the broadcast network. So these are the possible reasons why the R1 is not forming a neighbor relationship. So these all should be same. OSPF network, hello and the dead interval and both should remain in the same area. Though this is how you can troubleshoot the OSP version 3 issues. I hope you enjoy this video. Thanks for watching. Please subscribe me for more videos and have a wonderful day.